Okay, with that, this brings us to our next section. The next few minutes, we will have someone shed light on deploying AI responsibly. Wow. So AI not only brings unprecedented opportunities, as we all know, to businesses, but also incredible responsibility. It directly impacts the people's lives and has raised considerable questions around AI ethics, data governance, trust, and legality. As organizations start scaling up their use of AI to capture businesses and their benefit, they need to be mindful of new and pending regulation and the steps they must take to make sure their organizations are compliant. That's where responsible AI comes in. Please join me in welcoming Dr. Harsh Vinayak. Dr. Harsh Vinayak. Dr. Harsh Vinayak to deliver a keynote on deploying responsible AI. Dr. Harsh Vinayak, Senior Vice President, Intelligent Automation and Data Services, NTT Data. And I see he's very excited already. Thank you so much for sharing.
Thank you. And how does this work? Is this the one?
You're asking a tech challenge person, but I think
that's the one.
It's an easy one.
Thank you. Wow, we're on the first slide already. Good to be here. Yeah, 3 years, I think, or 2.5. It's amazing to see this crowd here. Used to have it thrice a year. So great to be back here. And today we have a topic which has already been touched upon by the previous speakers. You heard Dr. Verma talking about cost of trust. Yeah? Cost of trust. He was talking more about cost of trust of humans. And then right now we heard that the single most danger of bringing in quantum computing, and it's real, is the break of trust in the internet. I mean, today we depend on 128, 256-bit encryption, which takes 100 million years, I believe, or something like that with your regular computing to break. With quantum computing, it's going to be a matter of minutes, maybe. So trust is an important factor that we humans essentially live on. And now we are talking about artificial intelligence. I'll explain that a little bit more as we go along. But we are talking about intelligence which is unlike ours, something that's new, something that's powered by maybe quantum computing to come with, super powerful. So how do we trust? Yeah, how do we trust it? Okay, so my background is defense. I come from aerospace defense for a number of years. For a couple of decades, I worked designing helicopters and worked with NASA and other defense organizations. So whenever I think about these things, the first thing that comes to my mind as story is the defense world. And so I have a few things here. These are dated, but then new things don't get declassified that easily. So if you go through the first one, I'm just going to tell the story. This is about NORAD, North America Defense Organization, 1979. NORAD is the agency in the North America, US, and Canada that's responsible for safeguarding an early warning system for any kind of attack on the North American soil. And one fine day in the morning when folks switched on their computers, the computer intelligence, and at that time, 79, I'm sure when I was programming in those times, it must have been some kind of decision table, something very simplistic. Nevertheless, it told them that there is a massive attack that's on its way. There were over a couple hundred ICBMs. They were only 20 minutes away from impact on North American soil. And that they had to reply, counterattack. And the counterattack protocol says you have to immediately do it because in 20 minutes, none of those missiles in the silos in North America would be functional. They would all be gone. Yeah? So this is what the computer was telling them. What did they do? Well, if we implicitly believed in our computing system, if we had infinite trust, the counterattack would have been on and we wouldn't be sitting here today. Probably was Armageddon. It's one of those Terminator things. But saner minds prevailed, and they looked at it, and they tried to corroborate it with satellite data. It didn't. It seemed like, and then they investigated it, and they found out that the technician from the previous night was running a test, a simulation on these computers, and he had forgotten to switch off that simulation. When the morning folks came in, they saw this, the computer system told them, hey, this is real. So right there, you see, this is extreme, yeah? This is existential, but it has happened 5 times that we know of. So this was on the US side, the other 2 are on the Russian side. Same things have happened, saner minds prevail. On one case in the 1995, President Yeltsin of the Russian Federation, he was given the launch codes. He was given that football, as they call it in the US, to launch a counterattack, but he knew that it was peaceful times, nothing was happening, and he didn't do it. Otherwise, again, it would have been Armageddon. So with that, though, let's come back to the reality of us. Most of us, for example, we are very familiar with these, yeah, with everyday things. So decisions made by AI are very useful. I'm one of those who is a huge proponent of AI, and I'll just touch upon what really I think about AI. But it can also bring in a lot of unintended consequences. And you have heard about all of these: employment discrimination on race, and the favorite one is the filter bubbles that come on YouTube and others that I get, and that only gives me short videos on the defense, on helicopters, etc. And I don't get anything on psychology, on sociology, and I'm missing something, right? So there is a bias. And why is this? So that brings us to, really, do we have confidence? And let's talk about these AI systems in very brief. As human beings, we are not statistical machines. Yeah, we think differently. We have patterns. We correlate stuff, but we are not statistical. We don't look at probabilities. We do it a very different way. Almost all the AI systems out there, artificial intelligence as we call it, are nothing but statistical inference machines, algorithms. Yeah? There are different ways. There used to be simple ways. Now you have neural networks and where you have multiple layers. But in essence, all these nodes are connected by equations which have coefficients, and you have an error function. You minimize the error function by adjusting these coefficients, and the more data you feed in, the more conformal your adjustments become, and then the output conforms to the data that you have fed in, and there lies the problem, the data that you have fed in. What if there's something on the edge, on the corner? Machine doesn't know how to react. It's going to give you some result which might not be true. So the questions that everyone asks is, of course, the user will say, why this outcome? Why did this happen? There are other stakeholders, business owner, can I trust it? A data scientist, is this the best model? So there are all these different stakeholders who are asking questions about this statistical inference system that we call artificial intelligence, yeah? So there is a real need. There's a real need to build a framework to somehow make sure that we don't fall in this trap of blindly believing something which is based on partial information, yeah? So what's happening? That's the other thing. When we used to do those expert system and decision tables, they were easy. Yeah? If you had an issue, you would go back and you would say, oh, yeah, this is where the if statement was wrong. Not anymore. Now you have like 20 layers, and you have these non-linearly coupled equations across these layers, and each one is a statistical entity, and you're adjusting all of those, and you have lost all human comprehension of what this model is. Yeah? Hence, everyone is racing to bring in regulations. Governments are racing in. Unless we bring in some kind of framework, some regulation, will be very difficult to harvest what this new technology gives us. This is our own. This is India's Niti Aayog's 2019, I believe, 2021, last year, came up with a very comprehensive, and I've gone through this several times, very comprehensive framework. A lot of work has to be done, but it's a great start. Yeah? Similarly, a lot of companies like us that code these, like all of you, you have all bringing in your own sense of how do we really be responsible in this field. Yeah? So we just heard Microsoft's in there, IBM's in there. This is NTT Data's. I mean, we are global, we are a large company, we have our own quantum computing labs, and we do a lot of work in AI, so we have to make sure that our algorithms have the right governance, the right organization, and we are doing good for the society. Yeah? All right. Now, I'm not going to go through any of these details because that's for our meeting, our panel discussion next, but there are several of these factors, you know, transparency and human oversight, et cetera, that is needed to be detailed out in order for us to start believing. Now, whether that belief is justified, that only time will tell, and repeated iterations will tell. Yeah? Well, this is what AI statistical inference looks like today. It's true. All right, so just a few of them. Human on the loop. We were part of the governing equation earlier. Humans governed the equations. Now equations tell us when we should be governing them or we should be looking at them. A change, can we trust that? And how do we know what's happening inside? There's something called explainable AI, and we'll talk about that again, I'm sure. Diversity. How do we really take care of diversity, yeah? It's different. I mean, we look different. We act different across the globe. AI and the data that has gone in might be biased towards one versus the other. So there's a lot of things that have to be figured out. That's not to say that there is an inherent, that there should be an aversion to the new technology. It's just to say we need to be careful like any other technology. In the end, just to close this talk, it's true. AI, just like any other algorithm, statistical, is not neutral inherently. It's not. We have to consciously design to make it neutral and to make it unbiased. So with that, I close my 10 minutes and invite the panel discussion team here. Yeah? So thank you very much. It was good to be in front of you.